All right, let's take a look at the second lesson in this Unit 6 for dual enrollment students only, and that is to do with work. We have three types of work that we'll be looking at, which are springs, ropes, and pumping of liquids. So you can't really start to talk about work until you understand force. And I know if you've taken physics, you've seen a lot about force, but we have to sort of ground ourselves in it for our applications here. So we think of force as describing a basic push or pull on an object. For example, a horizontal push of a book across the table, or maybe the downward pull of Earth's gravity on a ball that you tossed in the air. So we know that force, in general, if an object moves along a straight line with the position function s, then the force of the object in the same direction is defined by Newton's second law of motion as the product of mass and its acceleration a. So we basically say force equals mass times acceleration, and acceleration in calculus terms is the second derivative of our position function. So if s of t was position, then acceleration is its second derivative. So we're going to start looking at simple work. And work is, a term that we use in everyday language, and it's basically your effort that it requires to perform a task. But in physics, the term work actually has this technical meaning that depends on force. So we can separate work into two categories, and we're going to start first with the constant force. Constant force means constant acceleration. So if we're using just a constant force formula for work, we are going to take force, like I said, is a constant, and we define work as the force times the distance that the object had to move. So it's just work equals F force times D distance. So the problem with all this is the units. Wait till you see the table on the next page here. So we have two different systems. We have the metric system and we have the US system using feet and pounds, etc. So the metric system, force has the units of the kilograms times meters divided by seconds squared, and we call that a Newton. We measure distance in meters. And the work, because work is, remember, force times distance, we have the Newton meter, which is kind of a complicated way of saying a unit. So we've renamed a Newton meter as a joule, and we abbreviate it with J. Now, if we're in the US customary system, force is actually just the weight in pounds. It's a little simpler. Distance, of course, we use feet, but then we have this thing called the foot-pound, which is how we measure work in the US system. Okay, so then we're going to come back to this table, by the way, because you'll need to understand these units as we work through the problems. But we now need to talk about mass versus weight, because if you think about it, we just said that weight is effectively force using the US system, but that's not always the case in the metric system. So let's figure this out. When an object is lifted, work is done against the force of gravity. So by Newton's second law, the downward gravitational force acting on the mass is mass times g, where g is acceleration due to gravity. So again, the gravitational force is mass times gravity. And we're going to use gravity as 9.8 meters per second squared, and the mass, since we're in the metric system, we will put it in kilograms. So to determine the force, we're multiplying the mass in kilograms times the gravitational constant g. That's more complicated than in the US system, where we just use weight in pounds, and that weight is the force because it already includes gravity. So basically, that is the bottom line, that when you were given mass in kilograms, you have to multiply by 9.8, but when you were given a weight in pounds, you already have force. Now, let's talk about density before we go into any problems. So density is sometimes, instead of being given the mass or the weight, you're going to be given the density. The density is the mass divided by the volume. So ultimately, to get the mass, you just need to multiply the density times the volume. It's just one more step in this whole process. So density equals mass times volume, therefore mass equals density times volume. So this entire video was just setting up a bunch of background knowledge, and in the next video, we'll start looking at examples.